So let's consider a couple of cases where we actually can see what's going on with the orbitals. Now you can see here that hydrogen, remember that hydrogen's electronegativity is going to be 2.1 and 2.1 for the other hydrogen. They're going to be pretty good at sharing. They're going to have the same electron affinity, the same ionization energy, and as a result, the same electronegativity. So they're going to both be as good at getting and sharing the electrons as the other atom. Very uniform sharing. Also notice how the density is very squat. What's that really telling us? Well, it's showing us that there's a really good chance of finding the probability throughout this range. Look at how well it's sharing right here in the center. There's a lot of overlap, right? Now, the scales do seem to be a little bit different, but look at the difference with fluorine. Remember, fluorine is going to be a 4.0 and a 4.0. Completely covalent, right? But look at how little sharing is actually going on to the actual intensity of these peaks. Now, if I had drawn these to go all the way up on scale, you can see that we're still on track to either cap out somewhere up around here or to be going off of the page. Either way, you can see that we're talking about a really minimal amount of sharing on the scale of where the electron is likely to be. Over here, on the scale of where the electron was likely to be, it's been a lot of time in between. Here, very little. These are definitely like the two thieves breaking into the bank, constantly stealing from each other and trying to get everything for themselves. So let me go ahead and get rid of this. Now, if we were to do the same thing but put a hydrogen and a fluorine, again, the fluorine is going insanely off scale. And look at how little sharing is going on right there. It's still a pretty decent amount of sharing, but not on terms of the actual scale. This will still be covalent enough that it's not like the fluorine is totally taking the electron away from hydrogen, but boy, it's not spending much time over by that hydrogen, is it? Which makes some sense since it's going to be 2.1 versus 4.0 for electronegativity difference. My delta En is 1.9. That means they're barely sharing at all anymore. If I bump that up to 2, that's telling us the fluorine has actually stolen the electron. And it's occasionally giving it back, but it's mostly keeping it for itself, and it's not really a sharing scenario anymore. As it gets further and further toward a difference of 3.3, means that the fluorine stopped even pretending to be sharing anymore. That's what we're talking about for electron probability distributions when we're going through and thinking about electronegativity.